Howdy again, folks, and welcome to part 5 here on making a buck regulator. Last time we left off in the previous video having just finished our board layout, and in this video we'll be picking up and generating our Gerber files and then sending this board off to manufacture. We'll be using a provider called OshPark. I like them quite a bit. They make pretty nice quality boards. They are reasonably quick and very, very competitively priced, and they're local. They're here in the U.S. So that's a nice pile of features in their favor, and they do a good job. So I send most of my prototype work to them. If you watched the last video, you'll note that there are some slight changes I made to the board here while you guys weren't looking. I added the USB port here on the end. This is a standard USB socket like you'd find on your computer. And the goal here is that, if you have, like this board was originally designed for a Raspberry Pi, instead of having some sort of adapter cable or cutting your USB cable, because the Raspberry Pi uses that micro USB for power, is that instead of having to chop it and then solder in your negative and positive leads to these pads here on the board, we'll just add the option here for a USB connector, and you can just plug it in. So you don't have to use either. You can pick which one you want. You can solder in here. You can just not actually put a USB connector on the board, or you can put the USB connector on and use that. So that gives you some flexibility there. And then the other thing I added here was this resistor and LED here, because I realized one of the evenings, I churn over these things before I go to sleep. I realized one evening that I hadn't actually put any sort of indication on the board whether it was working or not. So here we have, this is our output 5-volt line here, and so I just tacked on a little line with a resistor and an LED so that when it's running, when it's actually outputting 5 volts, this LED will light up. So we just have a little power LED on there. So that's the changes I've made to improve the design just a little bit and improve usability. So I think we're pretty happy with things. We can go through and do our final checks, do our electrical check. It's just giving us a warning that, our LED part has no value. We really don't care. Our air wires, there's nothing to do. All the wires are routed, so that's good. We can check our design rule check. And you'll see here that I've got it pre-filled in with Lane's PCB order design rules. And you can get these from OshPark. Here I am at the OshPark site here, and up at the top here there's this design rules tab, and so I'll click that, and so they have their design rules tell us what they're capable of producing, what they can actually make for you. And so what you can do is you can download this file and load it into Eagle, and so they've created this file here that has all of their design rules in it, and so when you load it up in Eagle, then it's already got all of the stuff pre-filled in according to their specifications. So I just have to load this file, and then I can check against it. And so you'll see it's given me a couple errors, but we can review these here real quick and actually see what they are and see if we can ignore them or if they're actually important to us. So we click on one of them, and then Eagle goes and highlights it for us. And so in this case, it's giving us a clearance issue. And so what it's saying is that it thinks that the pad here for the inductor is going to be close to the pad here for this capacitor. And really, it's a very small overlap. I'm not concerned about that, so I'm going to ignore it. And there's another one on the other side. Okay, that's the same deal. And then keep outs here are where these red lines around these resistors here are the footprint designer said we need to keep so much space between these parts, and so we add this keep out line around it, this keep out layer that says don't put anything else within this line, just to make sure that we have enough space for, usually it's stencils or the pick and place machine to go and put these parts down. Now, I know with these resistors, this much overlap is no big deal. I mean, it's tons of space. I get in there with tweezers and a soldering iron. It's totally fine, so I ignore these ones as well. So that's the other side of that. Yeah, we've got the corners there. It's going to do each corner on each part and consider each of those a separate keep out issue. And then overlap issues. So it's saying that, again, there's going to be this area where it thinks that, there's the pad, there's the copper of the via here, and then there's the design rule that says how far from, some copper trace, anything, does something else need to be. And so what they're saying here is that these vias are too close together. And if these were like different, signals, if these vias were supposed to be carrying different signals, ground and 5 volts, something, a digital signal and a ground or digital signal and 5 volts, I might consider that, more of an issue. But since these are the exact same thing and they're just being used to allow soldering from the bottom and heat sinking from the bottom, if they cause a problem in touch during manufacturing, that's not going to actually impact me in terms of usability of the board. The board will be perfectly fine. So if the copper layers here end up touching because manufacturing, where they can't quite get the precision in the manufacturing and they end up touching, it's not the end of the world. So again, I'm going to ignore these. And so with that, I've covered all these errors. I know that all of these are good. So I'm just going to say I'm good with those, and that works for me. So we've got our finished design here, and it's ready to be exported. Gerber files is what I usually use. OshPark is kind enough. We can actually... they have here at the top where they say that they can currently accept Eagle files themselves, so you can send them your board file, and they'll take care of all that stuff. I usually don't like to do that because there's lots of junk in various different layers of the Eagle file that I don't necessarily want them to print, want them to put onto the board. So I export the Gerber files myself, and then I can choose exactly what layers and whatnot I want as part of the finished product. So what they have here is that you can generate your own Gerber files, and if we click this, it leads us to one of their support pages, and they have, again, they've been kind enough to help us out here, and they've provided a file here that's the CAM job, the computer-aided manufacturing job for Eagle. And so what it is again, like the design rules check, the design rules, they have a separate file that they've generated that says, here's how we take your Eagle file and generate Gerbers in a means that we understand. And so you can set all the Gerber parameters yourself if you want to, but they've provided that to us, and just make sure that they understand the Gerbers when they go to manufacture it. So if I go here to my main control panel and I go to CAM jobs, again, I've got that lane PCB order CAM job, and so I open that up and bring it to the right window here. And so right now it's I've just opened the CAM job, but it's not actually associated with a project that's in work right now. So if I go back to the board, and then I go to this tab here, it's called the CAM processor, and click it, and it connects that CAM job I opened up with the board I'm working on. And so now we go through, I can expand this so we can see here a little bit better, but so now we go through each of the main layers we want, our top and bottom copper layers, our top and bottom silk screens, our top and bottom solder masks, our board outline, and our drill file. And then we choose what layers we want to be included as part of that. And so when we're looking here, if we look at our board, Our red is our top layer, and then we also want to include any pads, i.e. our surface mount pads or our through-hole pads, and then also our vias, because all of these are part of the top copper layer, and then nothing else should be part of that top copper layer. Again, we'll do the same with the bottom, and these are all pre-filled out, which makes it nice for us. So I just go through and check manually myself just to make sure that I've got everything I want on there. So again, on the bottom, we'll have the bottom copper layer, which is in blue. You can see peeking out through the red there. And then our pads and vias, because they happen on both sides. We have our silk screens. And so then, this is, the silk screens are usually where I find that I end up making changes, is that, so the dimension layer is the outline of your board, and that's okay, I usually leave that there. And then the top placement layer is usually what I use for things that I want to be printed. And so when I go and add things, when I go and add text, you see I put it in the top placement layer. And so I want to make sure that's on your silk screen, on my silk screen, I should say. And then often, if I'm making really tight, really compact boards, a lot of the time I don't have room for a lot of the text around each of these. So a lot of times I explicitly pull these top names and top values off of the top silkscreen layer so that these things don't get printed. They're still in Eagle, and so I can reference it when I'm putting the board together, but I pull them off so that it's not trying to print these tiny things on the board weird and random and whatnot. But you'll see that if we click this is a it's a T names, so it's going to be names, and then this one would be a value, so T values. And so when you're creating these, you can specify different layers, and then here at the end you take which layers we want to actually put into the silkscreen. And so in this case, we've got room. I've organized the names and values in a way that I think can print reasonably well. So I'm going to leave those on. Sometimes I will take those off. Again, same thing here with the bottom silkscreen. I don't think we really did any parts on the bottom. We could have done so to make it smaller. Maybe put the big inductor here, because that's a huge portion of our board space. Put it like underneath the main part here, and that would have saved us a good bit of space, and just run vias down to it. But I usually don't like to do too much of a dual side load. It just makes it easier to put together at the end if everything's on one side. And I'm willing to pay the little bit extra to get a slightly larger board. So, and that's just personal preference, but you can do whatever you like. But I do have some, it's hard to see here, but I do have some text on the bottom where I have labeled like the plus and minus things here. This one says input, this one says output. So I have put text on the bottom, so I do want that printed. And so these are included in our bottom silk screen. Your top solder mask is just going to be your T-stop layer, and that's really just here on your pads and here on your pads as well, that they leave the copper exposed and don't put a coating over it. And so I usually don't show that in my working view. I can go in here to the layer settings, and I can enable my T-stop and B-stop, and it'll show me where it's going to keep the coating off of this and keep the bare copper. So if you wanted to, you can actually add, you can draw polygons and rectangles and lines in your T-stop and B-stop layer where it will keep the coating off, keep your solder mask off, and just leave the exposed copper. So you can use that for specific design functions. Some folks actually like to do that for their maker's mark or their logo or whatever, is that they'll add something in the T-stop or B-stop layer so that you get the shiny copper making your logo rather than a white printed silkscreen. It doesn't really matter. But I usually turn those off while I'm working because it's just a distraction from the view for me. But these are important things to have when you're exporting your Gerbers so that they know where not to put solder mask. Your board outline is just going to be your dimension layer, and all your dimension layer here is just this white outline that goes all the way around your board. That's just so that they know where to cut your board out. That's the full dimensions of your board. And then your drill file is going to be your drills and holes, and that's really the difference between your drills and holes is, in theory, your drills are plated and your holes aren't. But most folks just use drills, and most manufacturers will just plate any holes that they find, because if they have to change the process to do one or the other, it usually adds cost, and so for cheaper board manufacturer, they just plate everything. So if you have a hole and they plate the inside of it, but it's not electrically connected to anything, it doesn't really matter. So that's that. So we've got, looks like, all of our layers in reasonable alignment, and so I'm going to say that I'm going to process the job, and it's going to go through and run all the tabs. And so it jumped from here to here, it ran through all the tabs, output a bunch of files, and so now if I open up my Finder window here, because I'm on a Mac and I use Finder, I have a bunch of new files here in my project folder. So I've got my board outlines, my bottom layer, my bottom silk screen, my bottom solder mask, my drills, my top layer, my top silk screen, my top solder mask, all new files in here. And so I'm going to grab these files, and we don't need the GPIs, but we do need the GERs, the Gerbers. And we're going to grab all those, and I'm going to compress them, which is just stick them in a zip folder. And so I'm going to rename this to 5-volt buck 5-volt buck regulator. And so now I've got this zip file that has all my Gerbers in it. So now I'm going to go back here to OshPark, and actually this will probably make it easier. So we don't need these tabs. We're going to go here, and so here on the home page, this is, if we click home, this is where we show up. It's this Get Started Now button. And so it's going to let you choose to upload your board file or a zip file containing your Gerber files. And so we'll select a file, and we're going to do that, and open 5-volt buck regulator. And it's going to be a 5-volt buck regulator for our pi. And so I'm good with that. And so now when it's finished processing this file, it should come back and tell us interesting things about it. So, and it may take a second here. There we go. Alright, so it detected our board, it went and processed the file, and so it's found a board of 2 1/4 inches long by 0.7 inches tall, 0.7 tall, 2 1/4 long, and it's going to tell us it's going to be 785 for 3. It continued with the project name and description that we have, and it's generated little example images of what it thinks it might look like at the end. So we'll click continue. Alright, so now it's done little renderings on what it thinks the bottom, top, and drills and everything else should look like. And so this is an opportunity for you to make sure that everything's looking like you expect it to, that it's not messed up, that your Gerber files, convey the information you actually wanted it to. All your silk screens are in the right place, everything like that. Because this is essentially what they're going to print. So you check all your files, your drills. That's showing you where all the holes are going to be. Your bottom copper layer, your silk screen, solder mask, and your board outline. If you had a more complex shape, you can actually do various shapes, and so this may be more complex. In our case, it's a rectangle. So that looks pretty good. So we're going to approve and order that, and so we have our 3 boards. They do quantities of 3 at a time, so you do 3, 6, 9, whatever. So for 3 boards, it's going to be $7, free shipping, total of $7.85. So after you finish running through the checkout, they'll send you an email saying, hey, we've received your order, that we'll be adding it to a panel here in the near future, and that they'll send you another email when they add it to the panel, and then yet another when it comes back and they're shipping it to you. So usually I find it's a week and a half or so. It's usually pretty good. So yeah, that's that. And then next thing I'll be doing in the background while we wait is that usually I usually do it about a week before the boards are expected to arrive. So usually a few days from now, just because usually I'm being lazy about it, and I finish the board design late at night, and just send it off for manufacturer, go to bed, and then worry about ordering the parts the next day or so, because DigiKey will send them to me much faster. I'll order the parts and they might be out the same day, and then it'll just be the 2 days for shipping. So I can delay on ordering the parts a little bit. But what you can do as a tip is that if you go to File and Export and Part List, it'll export a list of all the parts it's aware of. And so then you'll get a text file like this here. And so it's got a list here, all of our capacitors, our diode, our input and output connectors, LED, our main inductor here, and our resistors, the main chip that we went and found, and then the connector here as well, the USB connector. Usually I manually go through and sort these out, but it's also a handy reference when you're going to look for getting all your parts ordered at DigiKey, is that it tells you what package it's in. This is a 1206 package, a SOD 323, power poles, 0603s, and then it also tells you your values. So it's a handy reference while you're going through and picking up all your parts. So anyway, we'll pick up this series when the boards come and when I have my parts, and then I'll try to figure out some means to record actually assembling the thing and doing a little bit of quick testing and see if we've got a working buck regulator here. So thanks for watching, and I'll catch you next time.